Hello guys, in this video I will be showing you the building blocks of SNORT rule by breaking each one portion with description. So let's start without further ado. What is SNORT? SNORT is the foremost open source intrusion prevention system, IPS, in the world. And SNORT IPS uses a series of rules that help define malicious network activity and uses those rules to find packets that match against them and generates alert for users. So if we draw a real life parallel, SNORT is your security guard. SNORT rules are the directions you give to your security personnel, and then the output is generated by that rule. So SNORT rule is a single line code that helps to identify the nature of the traffic. However, modern day SNORT rules cater to larger and more dynamic requirements and so could be more elaborate as well and complex. Also, you can use SNORT rules on cross-platform on any operating system. There's no limitation whatsoever, uh, be it Linux, Unix, Windows, Ubuntu, or whatever. And alerting a malicious activity that could be a potential threat to uh, your team, your company, your organization is a natural feature of SNOT rule. So crucial information like IP address, timestamp, ICPM protocol, IP header length, and such are traceable with the SNOT rule. So, so there are three mods SNOT rule use. The first one is sniffer, and sniffer modes help with your intrusion detection system objectives in the following instance. If such as if you need to print out data, you can use a sniffer. um, there is a need to see the data in transit, so that's also part of the sniffer. The second one is logging mode. Just like the term logging implies when you need to log record at the default setting, or you can provide your own directory with the options. And the third one is intrusion detection system mode. And in this one, administration is interested in logging a specific kind of data packet, and then you may run SNOT in network intrusion detection system mode. You may also find the action you want to take upon detection of malicious data packets. So this is the basic structure of SNOT rule, which comprised into two fundamental categories. One is called rule header, the other one is rule option. And then rule header is consist of parts such as action, the very first one. The second one is protocol. The third one is source IP address. The next one is source port, and then the direction, and then the destination IP as well as the destination port. So I will go over one by one and show you the detail of these parts of rule headers. So the very first one is before we go to the section, the building blocks, I will describe what else we can use in the SNOT rule. The first one is include. We can use include options similar to the C language hash include, and then we can include the file name and the path for the um, SNOT rule. And then secondly, we can use variable rather than have IP address or range of the IP address. We can use variable, and with the specific format with the keyword variable, and then the variable name, it could be anything, and then the value. So in this example, there is a my underscore net is a variable name, and the value is so the very first one, the part of SNORT rule is rule action. The rule header contains the information that defines who, where, and what of a packet, as well as what to do with the packet with all the attributes indicated in the rule should shown up. So the first item in a rule is the rule action. The rule action tells not what to do when it finds a packet that matches the rule criteria. So there are five available default action in SNOT, such as alert, log, pass, activate, and dynamic. So what alert does is generate an alert using the selected method and then log the packet. The log one just log the packet, and pass ignore that packet, activate alert, and then turn on another dynamic rule. So dynamic remains idle under activated by an active rule, then act as a log rule. So the next part is the protocol. The next field in a rule is the protocol, and there are three IP protocols that's not currently analyzed for suspicious behavior, such as TCP, UDP, and ICMP. But in the future, there may be more such as ARP, IGRP, GRE, RIP, and IPX. So at present, there's only three: TCP, UDP, and ICMP. So here you can see there is alert and the TCP, so that is a part. And the next one is the IP address. And after the TCP, we can use either variable by giving the IP address value in the variable name, or we can just put the IP address range. Example, you can see that this rule's IP address indicates any TCP packet with the source IP address not originating from the internal network. So there is a negation used. It means like this network, not in this network, and the destination address on the internal network. So this is IP address given as it is, and the port is given 111. So the rule IP address indicates any TCP packet with that source IP address, and then after the direction, the destination IP address as well as the port. So here you can see there is alert, then protocol, then IP address, and then port is any. So similarly, after the direction, another IP address and the port in the IP header. The next part is a port numbers. Port numbers may be specified in a number of ways, including any port, which is like a wildcard. It can be ranges, it can be negation. So any ports are a wildcard value, meaning literally any port. So static ports are indicated by a single port number such as 111, 23, 21, 80 for HTTP, 23 for Telnet. And then we also can use the range for the ports. Then the next one is a direction operator. Direct indicates the orientation or direction of the traffic that the rule implies to, such as the IP addresses and port numbers on the left side of direction operators is considered to be the traffic coming from the source host, and the address and port information on the right side of the operator is the destination host. So there is also a bidirectional operator which is indicated with that sign here. This tells SNOT to consider the address port pairs in either the source or destination orientation. So this is a handy for the recording, analyzing both sides of the conversation, such as a telnet or POP3 session. So this is an example of the bidirectional operator. So rule option from the heart of SNOT's intrusion detection engine combine ease of use with power and flexibility. All SNOT rule options are separated from each other using the semicolon. So this statement implies to the option part of the SNOT rule, and in that all these rules are separated by a semicolon. And I'll show you in the coming example. Rule option, which is a second part in the parentheses, keywords are separated from their argument with a semicolon. As of the writing, there are 15 rule option keywords available for SNOT. So there are 15 keywords which can be used in the rule option section of the SNOT rule, and I will show you all of them in this slide. There is a message, print a message in the alert and packet logs, then log2, then TTL, then TOS, and all those others. So these are all 15 keywords that can be used in the rule option. So what is rule of thumb or the good practice to create a good rule? So there are some general concepts to keep in mind when developing SNOT rules to maximize efficiency and speed. And the important one is the case sensitivity. Same like Java language, it has to be the keyword has to be in uppercase unless you use no case option. So when we write, so in this example, the second of these two rules will catch most every automated root login attempt, but none that use lowercase character for user. So here is that example. Select all, then start SQL. And here you can see all the alert IDs. So let's pick a couple of them and see where the SNOT rule implies. So I click this one, and after highlighting the one, we can see what is the source IP, what is the destination IP, and show packet and show rule. So this is the place on this tool to see where the rule implies on the system. So this is the rule which is with the keyword alert and protocol of TCP. Then external net is a variable, and then the second variable is a port, and then it is the operator for the direction from this side to the other side, and home is IP address variable for the destination on any port, and then is a header option. So this is header rule and this is header option. So in this example, we have a variable for the IP address and the range of ports given on the source side, and after the direction it is a wildcard any, and then this is a rule option part. So this is all I have on this topic about SNORT rules, fundamental and basic building blocks. So if you have any question or comments, please go to the comment section below. Also subscribe this channel and press bell icon to receive new videos notification. Thank you. Bye for now.